Thank you everyone to join us. Today with Demetrios, we want to introduce you to MLOps. And in particular, we want to talk about why, what, and where of MLOps. So this is the agenda for today. I'll talk about reasons to consider MLOps. Then I'll provide you a definition of MLOps and MLOps, and I'll show a basic example of MLOps I demo for SaaS. And finally, I'll ask Demetrios to join and present to you MLOpsCommunity, which is this fantastic place to talk and share about MLOps. So if you are with me, we can start. So first of all, a couple of words about me. Who am I? Someone told me that I look like an expert, but I don't think so, because essentially I would say that I'm just a person passionate with MLOps who joined SaaS 2 years ago. And now I work every day for efficiently moving analytics model from development into production and deploy them at scale. So I usually spend a lot of time collaborating with data scientists, data engineers, IT developers, and open source experts to design and prototype machine learning system for delivering expected business value using analytics. So Demetrios, can you introduce yourself, please?
Yeah, so as Ivan put in this this slide, I don't know if I'm democratizing MLOps, but what we're really trying to do is create a place where we can talk about the whole operationalizing side of MLOps. And I got kind of thrown into this about 9 months ago because of the job that I was working at. I had no idea what I was doing when it came to machine learning, and I was thrown off the deep end, and I started talking to a lot of people, and slowly but surely I started learning, and that's basically how I got into this. And and I like to say that I know just enough buzzwords to make it seem like I know what people are talking about.
Okay, thank you, Demetrios. So let's move on. As I mentioned, I will start to justify why MLOps, in particular why I personally started looking at MLOps. So before to answer this question, I will collect some facts from you. So that's why I think about an online survey. So if you have some QR code to read this picture, we can have this survey. Let me try to do that. Okay, so you should be able to see the screen, and actually you should start to vote in a way that we can see in real time the answer of the let's say the survey. This is the right. Could you let's say read this QR code?
Yeah, it says your presenter will start the poll.
Okay.
Please stay tuned.
Okay, perfect. I don't know why I get this stuff actually.
The suspense is
okay, perfect. Perfect. Okay, so as I can see, Okay. So, okay. So most of all are data scientists or other or has other job role. So let's move on. Okay. So 10% of you consider the model just a piece of the puzzle. So, and I like that, okay, maybe less. Okay. So we are all agree that model is just a pieces, right? So with this survey, that's something that that's what I will really like to let's say share with you, because essentially, as the surveys with these surveys, I try to show you which is the general perception of the model. Generally, when especially when I talk about the customers, customers think at the model like the core component. So this is the perception I face from customer side. But in the reality, and as you just let's say confirm to that, the model it's just count just the 5% of an entire machine learning platform, and that's why I start looking at machine learning system and MLOps, because when I joined SAS, everyone were focused on build cool models, just try to find the best parameters they can, and then okay, they just at the end they start thinking about okay, how I can operationalize this model. So as you probably know, then why model counts just for the 5% of the machine learning system, because all the rest is needed to put the model in production, and that's difficult because model has some hidden complexity that needs to be managed. And today I will just give you some example about why maybe so hard to operationalize model. So, and I will focus it on data scientist problems. So, for example, one of the main problems I see that data scientists has, it's about experiment tracking. So you probably, I expect that you do some code versioning, but what about parameters? What about data version? This kind of stuff, I based on the meeting I had, it's something that, let's say, it's really painful to monitor, to, let's say, document on the customer side. So it's a really, they represent really interesting challenges. Another point I would like to ask you, maybe in a sort of question, if I ask you if your model is can exactly reproduce the same probability whatever in the right environment you run it, are you sure about that? I mean, you're sure that you can get the same exactly results in terms of probability from your model, and this result is environment independent. This is another point, and which is something related to reproducibility of the model. Last but not least, the topic of continuous training and traceability. So essentially, this point is related to the capability to release a new version of the model in an automated way, whatever happens to the data. I mean, if the data change, you have at the moment in production a system that just let's say trigger and start the retrain of a new model. This is another aspect that I see it's so hard to implement when you try to deploy model in production. So of course, these are just few examples of the complexity the model has, and in general, this kind of complexity affects factor like time, resources, and the quality of the project. So you need to evaluate them, and of course the main question is, how do you reduce the time between analyzing the problem creating the models, deploy the solution, and then maintaining the quality of the output. This is one of the main questions that you have to ask yourself when you start thinking about operationalizing a model. In software engineering, you can answer this question thinking about DevOps. So in DevOps, essentially, you have software developers who works on the project. They usually, let's say, don't work all together on the same code at the same times. In general, what they did is just use a version control system. So they check out the code, they start coding, then they push the code, and then an automated system tests the code. If the code is okay, just merge it, and then build, test the entire code again, and then release. So all these steps of building, testing, release the software runs in this short cycles. And then the part that I just mentioned is automated thanks to, let's say, practice related to CI and CD, development. So all these concepts that I just covered up are so important as well when you start to, let's say, think about machine learning operation. But models, analytical model as an important aspect to consider also, which is represented by data, because the predictive power of the model depends on data profile. And of course, data profile change during the time. So when you build a machine learning system, you have to think about continuous integration, continuous delivery, and then another terms needs to be covered, which is the continuous training. So at the end of the day, what you have is a kind of this process. So from the left on the right, you just once you get the data, you just start experimenting. Then you find the best model, you version the model, and then you need some kind of CI/CD mechanism that based on your models, test, build, and version the pipeline. The pipeline is deployed. And now this is the new pieces of the puzzle. The model is served, needs to be monitored in real time. Based on the data that you get from the monitoring part, you create some measure, and based on the measure, you create a trigger or some kind of threshold that trigger the retraining. Then the new data, the data are ingested, the live data are ingested, and then you can use the data that you get from the field to start a new, let's say, training cycle. And so all this stuff together create what we, let's say, call a machine learning system. And let me say, all practice that make this process feasible, they are just represented by MLOps. As I mentioned, there are other aspects to consider when you talk about MLOps and to understand why MLOps is so important. For example, there are this idea of the technical debt that has an high interest rate in machine learning compared to the software engineer, because essentially technical debt is, as you can imagine, are, let's say, just to simplify, are all the bugs that you fix on the fly because time matters more than quality in a certain, let's say, situation when you have to deliver the project fast and you don't have too much time. But in machine learning engineer, this kind of, let's say, practice costs you a lot because could you imagine the butterfly effect that you have using this kind of approach, because all dependencies that a model has in production. So that's another point I would like to just underline for you. And finally, of course, there are a lot more complexities that you need to have in mind, like to create a model, you have different expertise that comes together in a team. You have to experiment a lot, testing is more complex than software engineering, because you have to consider data as well. Deployment itself, the entire process may be challenging, and then once you deploy the model and you start serving it, you have also think about the measure you have to define to trigger and start the retraining again of the model in case data patterns change. So as I mentioned, all these process that I show you so far, all the good practice around this process are represented by MLOps. So we just using a definition from Google, MLOps is a lifecycle management discipline for machine learning, and its goal is create this balanced process for approach the management of resource, data, code, time, and quality, of course related to the machine learning analytics model, to achieve the business objectives in respect of policies like for, of course, compliance and this kind of stuff. And of course, thanks to, at the end of the day, thanks to this practice and the cycle I described you can get machine learning system in production like the one I show in this picture. So essentially, you have this exploration and development phase. Once you get the model, you CI/CD practice to build the pipeline, package the pipeline, and deploy in production. Once you deploy in production, you test the pipeline and version it, and then you serve the pipeline. And once you serve the pipeline, you start to collect the live data and reuse it, store it in a future store, and then reuse it to, let's say, start a new training phase. Okay, so now that I give you some idea of why MLOps and what is MLOps, because I provide you the definition, I will just demo for you some of the steps I mentioned in the before. So, and I would like to do so, showing you this demo I built using MLOps platform provided by SAS. So as you can see from this picture, from the on the bottom left, you have the data scientist that runs TensorFlow model experiments in development environment and track them using MLflow. So then using libraries, open source libraries provided by SAS, you can register the model in our MLOps platform. This platform has two main components, SAS Model Manager, which is a kind of model registry, and SAS Workflow Manager, which is a kind of orchestrator that allow you to, let's say, integrate models that you register in the Model Manager with a third-party system. You can use this orchestrator to, let's say, send emails, execute REST API call, all this kind of stuff. So in this case, once you register the model, we use the Workflow Manager to validate the model, build the Docker image associated to the model, and deploy the model in an OpenShift registries that I hosted on AWS. And here, once the model the Docker image is registered, I just simulate this stack to score, to consume the model and use it for scoring purposes. Then I storage the live data, as I mentioned before, in a Postgres DB, and using the connection from the platform, we are able to, let's say, collect the data and use them to create this dashboard for about performance. And based on the value that we get from a particular statistics that I will show you, we just trigger the retraining of the model. And of course, all the process, because Workflow Manager is able to, let's say, send emails and do and does REST API call, is let's say, you can, let's say, you can know about the process just looking at the message we send in the Microsoft team for collaboration purposes. Okay, so this is essentially the idea of the demo. So as I mentioned, the demo is composed by different pieces. Today, I would like to show you the part of the deployment and probably the monitoring and the retrain. And then I'll ask Demetrios to talk about the MLOps community. So let's start to deploy the model. Let me know if you see the screen. I think so. Okay. So as I mentioned, we registered the model in our MLOps model registry, let's say. And so the project is called SAS MLOps TensorFlow OpenShift. Each project has different tabs, as you can see. In this part, we just show you the tabs related to the orchestrator. So you define a process, and then with this tab, you start it. So we ask the user to provide some, let's say, parameter for this orchestrator. For example, the name of the project, if we want to receive email or just Microsoft Teams notification, and then the value of the statistics we want to use to trigger the retrain when the model starts underperforming. So let's switch on the workflow manager GUI, which allow you to, let's say, see and build, especially build this process. So as I mentioned, we have different tasks, both service task and user task. Service tasks are represented by automated stuff you can implement with this process, and then user tasks are just tasks that ask the user to interact with the system. In our case, the first tasks ask to provide some metadata related to the process, and the second tasks asks to, let's say, approve the champions model. So the model that you want to put in production. So we approve the champions model, then we provide the tag we want to use to register the image in the OpenShift registry, and then we complete. So once you complete that, behind the scene, you are deploying the model. And as I mentioned, because we integrate with this orchestrator, we integrate the entire process in the Microsoft Teams. As you can see, we just received the notification that the model was approved, as I showed before in the video. And now we are going to receive different notification that let us know that the model is gonna be in production. So it's gonna, actually in this case, it's gonna be registered in the OpenShift registry. So as you can see here, we get the message, and in a couple of seconds, I think I'm gonna reply Artems, which is a colleague I collaborate on this project. I'm so happy that the model was deployed. So let's switch on the OpenShift GUI. As you can see on the right, we have our project we used to deploy models, and on Kubernetes cluster, on managed Kubernetes cluster using OpenShift. So here you have all the image streams that I'm gonna use. And here you have the model that you just registered with the tag 1.0.0 that I showed you before. So in the deployments view, I'm going now behind the scene. I just, let's say, deploy using the manifests. And so here the pods are running. And in a couple of minutes, yeah, they're gonna be active. And so you have different pods. First of all, you have the logger, which is the pods that just track, let's say, the file that are gonna store the live data to be registered in the Postgres at the end of the demo. This is a kind of best practice to store logs in Kubernetes. So that's why I decided to use this practice. And then in Champions model server, as you can imagine, I use the TensorFlow server to serve my model using to expose my model here, let's say. And the last pods I'm going to show you in this demo is the pods that essentially simulate a scoring scenario using the server I mentioned. So as you can see here, this pod is just submit score request to the pod that contains the model. So this was about the, let's say, the deploy. So imagine that you deploy the model and you store the live data using the CSV. You can, let's say, from the OpenShift environment, you can use this port forward, and you can expose the container with the Postgres. And thanks for the access to the platform, we can read the data from this Postgres and consume in a real-time dashboard for performance purposes. So in this case, starting from the orchestrator, from the, let's say, the workflow I showed you before in the production stage, here is all the process that we define to do this stuff. So as you can see, we just, let's say, we have some clock item that allow us to schedule this kind of practice if you want to schedule it. And then we have the task, the service task to execute the performance. And here, once the entire process is running, you get this really, let's say, insightful graph about the performance of the model. So with different statistics, you have ROC, you have Gini, you have Kolmogorov-Smirnov statistics, and then you can use these statistics to track your model, depending on, let's say, the time windows you define. In this case, we just simulate it, so we decide to use quarterly time windows. And based on these statistics, then you can decide to, let's say, automate the retraining. Notice that at the beginning, we set a threshold of, if I remember well, 0.44, and the statistics go down on 0.43. So as you receive the notification, as I show, that tells you that the model is starting underperform. And then at the end, you have to retraining it automatically, because using this trigger, you can, let's say, define the workflow to do this stuff. So, and the last part of the demo start from the notification, and then show you that the workflow was successfully completed. So if we go in the project stage, we can see from the top to the bottom that the performance monitoring was executed successfully. We get the performance. Then based on the trigger, the threshold you defined at the beginning, the retraining was triggered. And then at the end, a new version of the model was automatically retrained, and the version again in the repository. So you get the second version of the model. So that's my demo that covers the main steps of MLOps lifecycle. So now I will ask Demetrios to introduce you where you can find useful information about MLOps. So Demetrios, the stage is yours.
Right on. Thank you, Ivan. And yeah, I think that this is something super pertinent for most of us who are doing data science. And if we have been playing around with models and we want to actually make a nice business value out of them, then getting them into production and operationalizing them is a very important piece of it. And that's really what we're trying to do at MLOpsCommunity. I'll throw in the chat right now a link to our MLOpsCommunity Slack in case anyone wants to join that Slack. What we are doing is trying to foster discussion around this, not only with tools like SAS, but other tools that can help this whole process. I think that there are many tools that are popping up right now and many ways that you can architect your whole pipeline. Like Ivan showed in a few slides back on the slide from Google, where it gave the whole ecosystem and all these different pieces that you need. You know, you have to be aware of monitoring. How are you going to deploy it or serve your model? How are you going to have a feature store attached to it? What are you going to do with the model registry? All of this is super important when it comes to actually bringing it out and making sure that you're I'm getting a bunch of notifications right now that some people are joining Slack. So awesome. Yeah, go around, jump in the Slack. We have a lot of good conversations there. And luckily, we have a lot of experts like Ivan who are happy to help if you have any questions. And if you are trying to productionize any of your models, this is a great place to just ask questions. And so apart from Slack, we have a YouTube channel that you can check out and you can look at. There's meetups every Wednesday. And so we have meetups quite like this, where we get together and we talk about different pieces of the puzzle when it comes to trying to figure out this whole MLOps universe. And along with the meetups, we also do podcasts and we have a newsletter, and we like to share everything that is important in this MLOps universe. So if you find a piece of information important, feel free to share it with us. I think Ivan will attest that it's a very open and inviting group, and there are no, because it is so new, there are no like people that will frown on your questions. And I think that's one thing that I try to make very, very clear, is that feel free to ask whatever questions you would like, no matter how beginner you feel like it is, because right now this is something that we're all exploring together and we're all trying to learn together. It's not like there are people that have been doing this for 20 years. And so you don't get people that are super experts. I mean, the people that have been doing it for the longest time are people at like Google and Uber. And a lot of these people are in the chat and they've been doing it for maybe 5 years or 7 years, right? So that's my pitch. I think I've mentioned enough. Ivan can tell me if I forgot about anything. But
yeah, maybe I can jump in just to say that about the, let's say, the openness and the how much is collaborative this community. Maybe we can mention also the engineering labs.
yeah.
Maybe it's a good audience. So just to mention you guys, in August we start thinking about this initiative that we are gonna announce officially this week, maybe the next one. Is called Engineering Labs. So just to spend a couple of words, essentially what we want to do is to create this kind of labs that just, let's say, template, let me say in this way, some common scenario about operationalizing model in a way that we can create a sort of knowledge hub that you always that you can see as a main reference. And when you have to, let's say, when you face a challenge on related to put model in production, you can find there some useful resource to see how we, let's say, manage the same challenge in these labs. So it's, let's say, it's a collaborative initiative. So if you want to join, just reach me in the community because I'm follow this initiative, and yeah, I mean I think we are good, right?
Yeah, and that's something that I think is really important, to try and get more hands-on experience doing this, right? Like, I'm sure you all have a good amount of hands-on experience with models and tuning them and getting the F1 score and making sure that there's really good accuracy. But what we're trying to do is create the other piece of that puzzle and getting this hands-on experience, serving the models, putting it out there, and seeing if you can create some business value from it. So I feel like it's a very important piece of the puzzle, and I know Yvonne does also. And I'd love for you all to join us in the community. And I appreciate you letting us come on here and pitch you the community. Hopefully we see you in the community, and feel free to reach out and be chatty. And it's yeah, it's exciting to have you there.
For me as well. So thank you all of us.